let's implement these three methods together. This one is from multiple students. We can implement equal method using these two methods. So if this set T is subset of self T, then it's going to, and if this T is both subset and superset of T, then that means these two sets are the same, all right? So that is one way to implement this method. And another way of implementing this method is we can, because this method can be somewhat expensive, we can avoid using this method. So that is, if len self is not equal to len T, then we are going to return false and return whether self is subset of T, right? These two implementations or solutions are both okay. However, this one is somewhat more efficient because it uses just one method call, all right? And another way of implementing is subset is this one is from Hanjun. So firstly, we're going to check all the elements inside our list. And if this element is not in this T set, then that means S is not subset of T, right? So we're going to just break this for loop and we're going to return the result, all right? So this is simple to implement. And lastly, we're going to implement eSuperset method. So this one is from Hagen. You can check all the items inside this T. And if this one is not inside this set self, then we're going to return false. Otherwise, we are going to return true. So this superset implementation is similar to this eSubset. However, another way to implement this method is using the method we already implemented. So we're going to just return whether T is subset of self like this, all right? So these two implementations look similar. So we're going to remove this part and we're going to use this method instead, all right? So up to this point regarding these three methods, is there any questions? Okay, cool. These three methods are pretty simple to implement. And from now on, let's have a look at some applications of sets. The first one is a simple spell checker. So what we are going to do is we are going to read some text from our Google Drive. So how can he build the spell checker? That is very simple. This is the list of words. So these are some words. And we are going to make a set and store all these words, valid words, inside our set. And we are going to check whether a given word is inside this set or not. If this given word, where we want to check whether that is a valid word or not, is inside this set, then that is a valid word. However, if it is not inside that set, then it is not a valid word. So let's implement what I meant by this. Given word, we are going to check whether this given word is a valid one or not. So we're going to read words from this text, and we're going to store all these words inside a set that is going to be words. And if this given word is inside words, then we're going to return true. Otherwise, we're going to return false. So this is a very simple way to implement a spell checker. So we are going to read this text, and we are going to make a set like this. And for each word, we're going to read each sentence inside this text. And we are going to add this word to this set, all right? So this is how we construct a set of words, because we do not allow duplicate words inside this set. And it is going to be our dictionary of valid words. And we're going to check whether this word, given word, is inside this dictionary. And if it is inside this dictionary, then that means it is a valid spelling. Otherwise, it is not a valid spelling, all right? So this is very simple to implement. And another application is sieve of Eratosthenes, in Korean, Eratosthenes의 책. This is to find the prime numbers smaller than given n. We all know how this works. So let's review how this algorithm works. Let's say we want to find prime numbers smaller than 20. Then we start from number 2 and remove all the numbers that is multiplication of 2. So we start from here and remove 4 and 6, 8, 10, 12, 14, 16, 18, and 12, all right? And next, we move on to the next number, which is 3, and remove all the numbers that are multiple of 3. So we are going to remove number 9 and 15 like this. So this is the algorithm of sieve of Eratosthenes. And we're going to implement this function. And this is our PPP problem.